Welcome, friends, to Physics Live with Ankul Bhattacharya. Today, I will discuss about the section of analog electronics in which we are interested to discuss about the oscillator. Now, before discussing oscillator, we have to know first what is oscillation. We all are well known about the term oscillation. Oscillation is nothing but the to and fro motion of a particle along a fixed path. It may be a straight line or curved line. In case of simple pendulum, we have noticed that the string makes an angle which is very small, less than a 4 degree, so that the path disturbed by it will be almost straight line. Now, the term oscillation is well known to us, but we are interested in sustained oscillation. Now, what is sustained oscillation? Sustained oscillation is nothing but the periodic oscillation with constant amplitude. That is, if we plot some waves so these are three waves or oscillatory motion. If we plot the oscillatory motion of a particle along a particular direction, say x-axis, let us suppose the direction is along x-axis, then we have three cases. In the first case, the amplitude remains constant. In the second case, the amplitude gradually decreases, and in the third case, or the last one, the amplitude increases rapidly. Among these three curves or these three variations, the first term is known as sustained oscillation, as because the amplitude sustain its constancy. Amplitude sustain its constancy along the x-axis, that is, the amplitude remains constant in the direction along x-axis, whereas in case of the second and third case, the amplitude increases and decreases. The amplitude decreases and increases respectively. So the first one is known as the sustained oscillation. So this is the sustained oscillation. Now, what is oscillators? Now we can describe or we can define the term oscillator. Oscillator is nothing but the circuit that provides sustained oscillation. And what is sustained oscillation? We have done it. So oscillators are the circuits that are used to obtain sustained oscillation. Okay, so this is the oscillator. Now, oscillator can be mainly of two types. The first one is sinusoidal oscillator, and the second one is relaxation oscillator. Now, in case of sinusoidal oscillator, we can represent the oscillatory motion by this, but you should not have any misconception regarding the sinusoidal oscillator. You may think that the sinusoidal oscillator always provides the sinusoidal wave of oscillation, but this is not true. Sinusoidal oscillator means the oscillator which can produce any type of periodic motion or periodic oscillation. That is, this type of wave can also be sinusoidal oscillator produced by this type of wave can also be produced by the sinusoidal oscillator. This is known as sawtooth wave, and the triangular wave can also be produced. But it should kept in mind that all of these should be periodic wave, or periodic, should have the periodicity. So sinusoidal oscillator are nothing but the oscillator which produce periodic oscillation. And the second one is a relaxation oscillator. It should not have any periodic motion. I have a great example regarding the relaxation oscillator that you will notice if you have a washing machine, that so that you can notice the relaxation oscillator. Now the function of relaxation oscillator, the circuit may be on for some time, and maybe off for some time. That is, it should not have any periodicity, but it remains on for some time and remains off for some time. Like washing machine, you can wash your clothes when it is on, and you will notice that when it is working, it remains paused for some times after the water collected by it, and then it again goes through the processes, and the mixture of water and soap bubbles etc. are generated, and the cloths remain within it and washed quickly. And the rejection of dirty water, or the rejection of the polluted water is rejected by the outlet pipe, and the machine gets paused for some time after collecting the water and collecting the soap that you have used, and then it starts working, and again it remains some time paused, and then again it starts working. So in this way, by switching on switching off mechanism, the washing machine run. So it is a great example of the relaxation oscillator, in which the oscillator remains remain on for some time and remain off for some time. So it should not have any periodic motion. Whereas in case of sinusoidal oscillator, we have noticed that it have periodic oscillations. So these are two types of oscillator. Now sinusoidal oscillator can also be classified into 4 types of oscillator. What are these? First, RC coupled or RC phase shift oscillator. Second one is Colpitts oscillator. Third one is Hartley oscillator. And the fourth one is Wing-Bridge oscillator. Wing-Bridge oscillator. So these are 4 types of sinusoidal oscillator. We will discuss point to point in our upcoming lectures, but today I will discuss about the great theorem or great condition, you may say, that is the Barkhausen criteria. Now we have to clean it. Let us talk about a general circuit, general electronic circuit containing an amplifier. So the circuit may be termed as amplifier circuit. Let us suppose this is the amplifier circuit, with the amplification factor A. Okay, and this is the input source, V input, and in this way V output is collected. Now what is the value of V output? Here, if V input be V and amplification factor be A, then V output will be A of V. V output will be A of V. Now you may notice that when we charge a capacitor, then it will act as a battery and the flow of charge from it continues till the capacitor discharge fully. And the discharge mechanism, you all are well known about it, and the expression that that describes the decay of the charge, you know. And so we can say that after prolonged time in the simplified amplifier circuit, you may notice that the continuation of this process result in heating of the circuit, which results energy loss in the system. And this due to this energy loss of the system, the output goes on decreasing, so we will not get any sustained oscillation. So we have to modify this circuit by the implementation of some new element. So after many experiments, we have come out that if we take some portion of the output and feed back to this portion to the input, and the input signal remains off, that is, this circuit is known as a feedback circuit. Feedback circuit with the feedback factor, you may say beta. Then the V output is AV and the feedback circuit provides a feedback factor beta. Then the input signal now becomes A into V into beta. This will become the input and this will go through the amplifier circuit, and again we will come out with new V output. The new V output will be obtained by this input and the circuit continues its process. So why feedback circuit is necessary? As because for the prolonged time when the simplified amplifier circuit is used, the heating process or some other kind of process may be generated in the circuit, so that it results in heating of the circuit and it results the loss of energy, and due to this loss of energy we will not come with the sustained oscillation. This will decrease and this is not desired. So to obtain a sustained oscillation, we have to use the feedback circuit, whose feedback feedback factor is beta, and due to the use of this feedback factor, the input becomes A V beta, and this goes on the amplifier circuit and new output voltage is obtained. So this is the reason behind the use of feedback circuit. Now if you carefully notice this input signal, that is V input is equal A beta into V. This term is very crucially important. Why? If A beta be greater than 1, then if we plot the input signal, we will get the amplitude will goes on increasing, which is not sustained oscillation. So this is not desired. So if in the second case a beta be less than 1, then the amplitude will goes on decreasing, which is also not desired, as because we always want to get sustained oscillation in which the amplitude remains constant. So if a beta be equal to 1, then we will end up with sustained oscillation, that is amplitude remains constant, neither increasing nor decreasing. So this criteria is very important, and this is known as the Barkhausen criteria. Barkhausen criteria. So this is our first lecture about the oscillators, and this is the Barkhausen criteria. We obtained this, and why this term is very important we all describe in detail, and why the feedback circuit is necessary, why the amplifier circuit, simplified amplifier circuit is not desired. All of these are described in this lecture. If you like this, please press the thumb button and subscribe the channel for more updates. Thank you.